Hello and welcome to this .NET Nugget session. It's one in a series of sessions where we spend 10 minutes or so looking at how we can do things with Visual Studio and the .NET framework. My name's Mike Tolte and I work in the Developer and Platform Group at Microsoft in the UK. And this is one of a series of sessions about the Windows Communication Foundation. This is a part of WinFX, which is concerned with building distributed applications. And in this particular session, we're going to take a look at how you can make use of different instancing models for the types that you build and expose as WCF services. So here we are in Visual Studio 2005, and I'm working with the September preview of WinFX. And I've built two simple applications here. One is a console application, and like so many of the examples in this series, it has an incredibly simple service contract which just exposes this one operation to print messages to the console. Now I've gone and implemented that with this implementation class, and the printing of messages to the console is fairly standard. The only different thing we're doing here is we are giving each instance of this class, so every time one of these is created, it gets its very own instance number. And as part of dumping this thing to the console, we include the instance number, so we can see how many of these things are being created. We have hosted this up with the service host, as we've done in all the other examples, and we've made this available at the moment over the basic HTTP binding. We've then built a client for it. The client is just a Windows form, and what the client allows me to do is to, in this very basic UI, specify a certain number of threads, start them running and stop them running. And when we start them running, all we do is we just loop through the number of specified threads, and we run this function here on that number of different threads. And all these things do is they create an instance of the proxy, they run around until they're told to stop, and they call the service from this particular thread. And just to identify themselves, they send their thread identifier over to the service. And that's it. That's the client and that's the service. So if we're just to run these two things, let's just bring up the service for a second, get our console onto the screen, and then if we go ahead and run the client, so let's just go and run that and bring that up onto the screen. And perhaps what we'll do here is just start with two threads calling the service. We don't need to be overly ambitious, because all we're really trying to see is that as we make these calls across, we're calling from a number of different threads. Here it's 3 and 5, and every single call to the service is being answered by a new instance of the object. So every single message that goes across to that service gets a brand new instance of that object, and once that call's finished, that object is presumably eligible for garbage collection. Let's just stop this, and let's just shut down the service. See that the reason why this is happening is that over on our service, we haven't specified for this class any kind of instancing behavior. And the way that we would do that is through the service behavior attribute. And one of the things we can do here is control instancing. And the available values we've got for this are per call, per session, shareable, and single. So per call is what we're doing at the moment, because every single call is answered by a new object. So let's just switch that to single mode or singleton mode. And notice this is a behavior of our local implementation. It's nothing to do with the contract. It doesn't leak out onto the wire or anything like that. And if we rebuild with that and go and rerun, then up comes our service, and if we bring up our client, and what we'll find is even if we get these 5 threads hitting against this service, then every single one of those calls will be handled by instance number 1, the one and only instance of our service type that the service host is instantiating for us. So singleton is very easy to understand. Of course, if we were doing this, let's just stop these threads over here. If we were doing this, we'd need to be pretty careful, because this all leads into the whole idea of multi-threading, because we potentially have a number of threads wandering through this single function on the service at the same time. In our case here, we're okay with that. In most cases, you'd have to do some extra work, and we'll come back and talk about threading in another session. Now the next mode that we've got to play with beyond singleton is per session. Now this links us back to the whole idea of session, which we've talked about in one of these previous nuggets. And if we were to try and do this at the moment, and to run our service, what we'll find is that at the moment we've got bindings that don't support session, so we need to switch our bindings. So let's just do that. Configure the client for the same type of binding. So on the client side here, what we'll do is switch basic to WS Dual. Again, we'll configure this up. Let's call this client configuration. Let's go and specify what that binding looks like. Once again, so that it matches the server side, let's switch security off here. And on the client side, we're also going to go ahead and specify the base address that the client will listen on. So here we have both the service and the client listening on HTTP. So on the client side, we'll go for localhost 8081/client. So now we're in a position where we should be able to build and run. And if we go and debug our client, then we'll stick with these 5 threads and we'll start those up running. And what we should find is that we will see up to 5 instances of the service type responding to the 5 threads from the client. So essentially what's going on here is there are 5 communication sessions from the client to the service, and for each one of those communication sessions we've spun up a separate instance on the server side. So essentially that, let's just shut this down and stop the service. When we're saying back in the service code that we want per session, what we're saying is for each communication session that the client opens up with the service, we will create a new one of these things. It will handle the interaction with that one session, and when the session goes away, and you can look at the details of that in the other nugget session, when that session goes away, we'll get rid of the implementation class at that point. So that's the per session instancing that we're doing. We do have this one last mode, the shareable mode. And what this is saying is it's just like the per session. So when a client makes a call across, he's going to get his own dedicated instance of this type. However, what that client can do is it can actually ask for a specific address that identifies that one instance that it's speaking to. It can then take that address and share it with some other client who will then be able to speak to the same instance. So it's almost like a way of introducing a friend into your conversation. You're having a private conversation, you bring somebody else in. And that's really what this is doing. With our existing client code, how can we demonstrate this? Well, let's go and visit the form we've got over here. And what we'll do is we'll add a private address. And let's call this instance address to this class. And we'll have a function, let's call it getAddress, and we'll pass it one of these proxies. And what we'll do here is we'll just lock for a moment, and we'll say that if the instance address is still null, then we'll ask the proxy to resolve the instance address for us of the object it's speaking to, and we'll assign that into our instance address. And then ultimately we'll return that instance address. So we've got a way of using one of the proxies, the first one that comes through here, to assign this instance address. With that in place, what we'll do is we'll change this make calls function. Let's pass a boolean to this as a parameter. So let's pass as a parameter, we'll pass whether count divided by 2 equals 0 or not. So for every other one of these objects, we'll do something different. So what we'll do is we'll interpret in here whether we should use the instance address or not as the parameter passed to us. And then if we're going to use the instance address, Then we'll say that the proxy address is equal to the results of getAddress, passing that proxy. So what we're saying is that for every other object or every other thread that goes around the loop, half of them are going to share one particular address, and the rest are all going to use individual addresses. If we just fix this obvious bug, which should not be count, it should be I, then we should be in business. So let's build, and let's run the service. And let's go ahead and run the client. And what we should see is that as we start up the client again, let's just run it up. And if we stop it down again, what we would notice here is that as the run went through, we can see that thread 3 and thread 9 and thread 12 are all sharing instance number 1, whereas thread 7 is speaking to number 2, and we have thread 10 which is speaking to instance number 3. So ultimately we've ended up with 3 instances here, one of which is being shared amongst 3 clients, and the other 2 are each individually servicing 2 clients. So we've managed to build that rather complicated scenario there with a number of threads, but fundamentally what we've managed to do is, by using the resolve instance call back in the form here, by using this resolve instance call, what we've managed to do is get the real address for one of these live instances and then share it with some other friends and allow them to speak to the same instance of the service type that we're speaking to. That's fundamentally what we're doing. Just to summarize what we've seen in this short session, well, we've seen that instancing is all about controlling the lifetime of the type that you expose as a WCF service. And there's 4 ways of doing it. We can do it per call, in which case we get a new object every single time a call comes in. We can do it via the singleton mode, which means one object for all the calls. And then we've got these other 2 options, private session, which means that we'll have one object to handle the calls from a particular client, which will go away when the client goes away. And finally, the same sort of thing, but shared session, where we can dish out an address and pass that to a second client, which can then make use of the same instance. So we can share an instance across a couple of clients. Okay, where would you go if you wanted to get some more information on the Windows Communication Foundation? Well, the best place to start is up at msdn.microsoft.com/winfx. And if you want to find some more information about the protocols, the web service open standard protocols that the Communication Foundation is capable of using, a good place to go for that would be msdn.microsoft.com/webservices. And that particular link we have on the slide here, /understanding, there's a great document there that specifies how all these things fit together to make a distribution platform as opposed to just a random set of specifications. And finally, if you want to follow up with anything you saw in this little session, feel free to drop me an email. My address is there on the screen. It's just mtolty@microsoft.com. Other than that, thanks very much for listening.